This is the Knowledge Graph Insights podcast, episode number 46. When your job is to help scholars and the public discover information about millions of cultural heritage artifacts that are housed in multiple museums, libraries, and other collections, you need a powerful but also manageable knowledge graph. That's Rob Sanderson's role at Yale University. He and his team apply time-tested ontology and knowledge engineering design patterns to help people discover and see the connections between these precious human artifacts.
Welcome to the Knowledge Graph Insights podcast, where experts on knowledge graphs and the semantic web share their wisdom with the digital and business communities. Our mission is to demystify and democratize knowledge graph technology and practices to make the benefits of knowledge graphs and semantic technology accessible to all. And now, here's your host, Larry Swanson.
Hi, everyone. Welcome to episode number 46 of the Knowledge Graph Insights podcast. I am really delighted today to welcome to the show Robert Sanderson. Rob is a professor and the senior director of digital cultural heritage at Yale University, the Ivy League school in Connecticut. Welcome to the show, Rob. Tell the folks a little bit more about what you're up to these days.
Hi, Larry. Thank you so much for inviting me to be part of the illustrious lineup of guests on your podcast. I'm Rob Sanderson, as you said, Senior Director for Digital Cultural Heritage at Yale. So I work with the libraries, the archives, and the museums and other collecting organizations at Yale to help them to be more connected with linked data and organizationally. And more coherent in the way that we do things digitally. So our projects really focus on discovery and access to the collections in service of the university mission, which of course is teaching and learning, research, and preparing our students to be the next generation of leaders in the world. So for that, the university invests very heavily in the collections, which is fantastic. We are super proud of the 300 years of collecting that we've done. But we want to make sure that, if you can't come to New Haven, you still have as good access to those collections as possible. And the ability to find amongst the many millions of objects that we steward exactly what it is that you need. So a lot of our projects focus on describing the collections in a more computationally tractable way, so that discovery can be better, and also how to manage the information that's associated with the collection, but isn't a museum object or a archival object itself. For example, I have 2 postdocs that are openly available. So if you are a few years out of your PhD or just about to graduate, do get in touch. To work on how to use AI to extract the ownership history or the provenance of particular museum objects from the archival content that we also manage. Equally, how can we align research data sets with the collections? So we also have a natural history museum as well as 2 art museums. How can we align the environmental data sets that are out there on the web with the natural history specimens that could have been impacted by those environments? And then equally, we look at the environment of Yale. So we have a large project at the moment to set up environmental monitoring with sensors for light, for humidity, temperature, and so on, to be able to generate a large data warehouse aligned with linked data with the collections, so that we can have evidence of what the effects of the environment are on the collection items themselves.
Interesting. That is so fascinating. What a fascinating remit. One quick thing about what you just said, is that like about humidity and temperature and all the things that might affect the endurance of these physical artifacts?
Yep. Yes.
So that, yeah.
Yeah. We have about 200 sensors around the place, monitoring every 5 minutes a new data point, which, if you think about it, is actually not that much data, right? 5.
But I have to say, I just love that you're doing data stuff along with it. So you're not just like some sitting in a dusty old room, collecting things. You're doing cool modern stuff too. But hey, I want to quickly interject how we met because, and I just want to kind of put this in because we won't have time to talk about it today, but I want people to know about this fantastic series you did. That's how we met, was somebody drew to my attention, the series you've done on ontology design and on knowledge engineering design patterns. And I'll point to that in the show notes, but I just wanted to mention, and the more I think about what you just said, because I didn't know all of this background before we started recording, I'm like, oh, this is even better than I thought. But so I'll point to that in the show notes. But the main thing I wanted to talk about today is what you were just talking about, this amazing cultural heritage operation that you're running there, especially the knowledge graph component of it, and how, and the AI, of course, because we're in the 21st century, and that's all anybody talks about. But can you talk a little bit about one of the things we talked about before we went on the air was the how AI is accelerating sort of the ability for you to build your knowledge graphs of these cultural heritage artifacts and data. Can you talk a little bit about that, like how AI is helping in that?
Yeah, of course, absolutely. So just a little bit of the background about the knowledge graph itself first before I get to the AI part. So over the past 5 years, we've built, without AI, a very large scale knowledge graph, and in cultural heritage terms, a very large scale, which has about 3 billion triples in it. And it follows the principles and the design patterns that you mentioned in those posts on LinkedIn. It then aligns the people, places, concepts, events, objects, works, collections that we manage here at Yale across the 2 art museums, Natural History Museum, the dozen ortho libraries. There's also a collection of musical instruments, the Institute for the Preservation of Cultural Heritage, and we even have a little outpost in London, in England, for art history research that we include. So that work uses the linked art ontology, which is based on the foundational CRM ontology, and is publicly available, both in terms of the data, you can just download it, but also in terms of the graph queries. We don't force you to learn Sparkle. We have a user interface on top of it, which allows you to generate queries and find the objects that you're looking for. So one of the things that we noticed first about the user interface is that only about 5% of searches are actually using the graph affordances. Mostly, 95% of the time, people just put in keywords because that's what they used to. Right? You go to Google, you type in your 5 favorite keywords that you think might match, and you scroll through the results. However, now in 2026, people are more used to typing in full sentences and then having AI take that natural language and process it somehow. So we are in the user interface phase of building out not a chatbot, but I don't think the world needs yet another chatbot, but instead a natural language processor that takes the user's research question, and translates it into the graph query that will take them to the objects that might help them to answer that particular question. So that's kind of our front end work. But in terms of actually building the knowledge graph, that's where we're focused, right? We, for many reasons. One, we have linear miles of archives, and not if you laid them edge to edge, but in a regular folder or books, of which only about 2 to 3% have been digitized. Of that 2 to 3%, most of them have not been described beyond just here is a folder and it's got some letters in it, or here is a box and it has a whole bunch of photographs. But that's it, right? You don't know what's on the photographs. You don't know who the letters are from, who they're to, what they were talking about, or anything. So we did an experiment, which was to use our high-performance computing cluster to do handwritten text recognition using large language models on 650,000 images taken from the archives. That then cost us about $1,200, including the replacement cost of the H200, right? Because it took about 120 hours. And if you divide up the cost of the H200, then yeah, $1,200. That would cost about $12 million if we were to pay people to do it, right? Because that's about 14, 15 people for a decade, just going through every single day, transcribing, page after page after page. So once we have the full text of the information, that's where we can start to process what we have in a way that makes it more discoverable, more computationally tractable. Got Weingart a couple of weeks ago, who was at the National Endowment for the Humanities and is now the CTO at the University of Virginia Libraries, said essentially that people will understand history through what is discoverable, not through what actually exists, right? And this is just a rephrasing of the old adage of if it's not on the web, then it doesn't exist. So how can we get, without spending that $12 million, to the point where those archives are part of the knowledge graph? So the handwritten text recognition is the first step, of course, along with PII detection and other, we don't want to expose people's personal information through some overzealous AI transcribing little footnotes and so on. But then we can use further language models to go through, understand the ontology, and which uses the same techniques as we do for the AI querying, and then produce from paragraph by paragraph, here are the triples which, according to the ontology, described in the paragraph of text. So, for example, imagine a letter from someone in Germany just after World War II to Alfred Stieglitz in New York City. And they're talking about the conditions in Germany and how, did you receive my last letter? So now we know that there was a letter. Right? So we can say Fritz Goetz corresponded with Alfred Stieglitz at this time. We know that he also corresponded on these dates, even if we, Yale, don't have those particular letters, because maybe they were intercepted by the German authorities, maybe they got read and thrown out by Alfred Stieglitz. We don't know, but we do know now that they did exist. And he also talks about correspondence with other people that we don't have the archives for, but other famous contemporaries such as Edward Steichen or Georgia Engelhard. We know that they were corresponding, even if we don't know what they were talking about. So that social network, then, you can't get from, there is a folder of letters, which is the only description of that particular collection that we had. Instead, by using the handwritten text recognition, we can expand the knowledge graph out from the objects into history, which then enables research and understanding of the past.
Yeah, that is so fun. There is so much in there. I have so many questions. The first thing that I want to mention, though, is that it occurs to me at the very highest level, this ontology is probably fairly simple. You only mentioned like a half a dozen kind of core concepts, events, people, was it like collections, works? So is it that simple, or am I missing something there? Is it?
No, we've tried to keep it as simple as possible. And this sort of falls back to those design principles where there is about 10 classes that we use out of maybe 30 or 40 higher level abstract classes, right? So we don't directly instantiate things like conceptual object or abstract physical thing. Instead, there are human-made objects, there are physical objects, there are intellectual works, and people groups and so on. So from those 10 classes, there's maybe 50 or so relationships between them. But yeah, the fewer things that we need to manage over the long term, and with cultural heritage, long term is really long term, the more sustainable it is, and the easier it is for us to work with over that time. And by us, I include AIs as well, right? So the better described, the more consistent, and the fewer overlapping relationships, the clearer it is for human developers and for the AI reading those letters to be able to determine which class do I need to use, which relationship do I use, and so on. So it is relatively simple, based on our experience, over the past 15 or so years building services in this space. But we also try to be extensible. So instead of trying to capture 100% of everything that anyone might ever want to talk about, we try to capture the 90% that everyone does need to talk about, and leave that last 10% for extensions. So at the moment, for example, we are looking at the archives of performances. So in theatre or at festivals and so on, right? What does it take to talk about a performance as opposed to a painting that hangs on the wall? So we're using that sort of extension model to say, and here is how within the foundations of the ontology, you can use the same consistent patterns to talk about this new domain. And because it's built on a robust foundational ontology, we have all of the concepts needed. It's not that they don't exist. We just need to select them and say, okay, this is the patterns that we use. Here is the new predicates that we're going to introduce between these few additional classes, and then rely on the good work of 30 years of ontology design, both in the cultural heritage sector and beyond.
I'm going to pull that out as a high-level benefit of building a good knowledge graph. But anyway, there's, again, so many questions. But one thing I wanted to ask about, we were just talking about the extension of the model. And as you described, they're quite simple, the highest level conceptual concepts that you're working with, but millions of artifacts. I'm wondering, do you know Dave McComb's notion of the C box? Basically vocabulary and taxonomy management. Yeah. Is that a huge part of this knowledge graph? There must be, because you just have works or collections, but you're across like all these different disciplines and kinds of artifacts. Is that all managed with vocabularies?
Yes. Yep. Absolutely. So it would be completely unwieldy if we had to, for example, say, here is the class of painting versus here is the class of book versus class of newspaper and so on, right? Particularly because we also have the Natural History Museum, the Peabody Museum, right? So then you have all of the taxonomic hierarchy of the animal and plant classes, and we're not going to create a new class for every single species. So we have to use taxonomy and vocabulary. Also, it means that the developers and AIs have that ease of use of the data, because at the end of the day, unless there's a new relationship between the classes, and hence you need them for domain and range, the fact that it's a painting versus a watercolor versus a print versus a sketch, the humans care about that, and we need to be able to display them. So we need a concept to say, this is a painting, find me all the paintings, and this is a drawing, find me all the drawings. But there doesn't need to be a class in the ontology. We can just use that concept notion with the vocabulary to be able to say, this is a one of these, or it has a classification rather than of painting. And one of the things which is very weird to non-art historians, but I'll try and explain it, is there is a widespread disagreement about watercolors. So a watercolor, right, it's a painting. Well, no, is it a drawing? So yeah, it's there is a widespread disagreement about whether watercolors are paintings or drawings. So we don't want to get involved at that level in the ontology that we need to keep around and be able to use. Instead, when they figure it out, it'll be part of the vocabularies and it will have the right hierarchy of narrower and broader terms using SCOS, and it will just work.
And the engineers,
they can argue about it all they want.
yeah, and so the subject matter experts can get their say in, which is the whole point of this thing. But the engineers are just like, just another vocabulary. Yeah, that's awesome. Hey, one thing I wanted to come back to, and I wanted to connect it to something else I wanted to talk to you about, was that notion that things don't exist until they're discoverable. That's so powerful, and it sounds like the opportunity here is so huge. But another thing you talked about in relation to that before we went on the air was about this notion of like people who don't have a Wikipedia page, like how do you resolve their entity in this? Because people must be a huge part of this, artists, and all this stuff is human created. Can you talk a little bit about that? Kind of discovering people who aren't well known and how to make them discoverable.
Yeah. I mean, this is a huge part of history, particularly in this era. The joke, what did Watson and Crick discover? Rosalind Franklin's notes, right, is something that drives us. How can we make sure that we are being responsible to what actually happened, rather than just following the famous names? The middle-aged famous white guys, he says, are the not very famous middle-aged, not very wealthy white guy, and instead, reveal the people who deserve the credit for what they did. And in the archives and in museums, that's where the information is managed, right, for history. So the more that we can use AI to extract the knowledge and then make it discoverable, the more we can bring to light those hidden stories. So one of the things that we've been experimenting with is using Wikidata and the links from Wikidata to Wikipedia to be able to then build a social network of people who are mentioned in either of those two data sources. So imagine in the letter from Friedrich Goetz to Alfred Stieglitz, he says, give my regards to Ida. Right? Without the social network, there's no way of knowing who Ida is. It could be one of a cajillion Idas. However, we know that Alfred Stieglitz was at the time married to Georgia O'Keeffe, the famous painter from New Mexico, and Georgia O'Keeffe's sister is called Ida. So it's almost certain that when Goetz refers to Ida, it's Ida O'Keeffe. So Ida is not, it does have a Wikidata entry. I forget whether she's notable in Wikipedia terms enough to have a page. But certainly the mother and father of Stieglitz or of the O'Keeffes, they are not famous enough to have Wikipedia pages. So, but they are mentioned by name. And there's information in the full text of the Wikipedia articles about them, just they don't have their own article. So mining the encyclopedic knowledge of as many open data sources as we can lay our hands on, not for the famous people, but for the people related to the famous people. Okay, so we don't collect every single archive of every single person. That we'd fill up many warehouses full of stuff if we tried to do that. But for the archives that we do collect, how can we make sure that the people who contributed to the success of the person to make them archive worthy, how do their stories get told along with the famous white guys? So yeah, that's we're relying somewhat on AI again to do all of that processing, to extract the linked data graph from the Wikipedia texts, and we use Wikidata as a way to then ensure that the records are reconciled. So if we have, for example, a person who is a painter in the Union list of artist names that the Getty manages, and maybe we also have a book about them. The Library of Congress manages the identity. And then the Library of Congress often refers to OCLC's VF, the Virtual International Authority file. And VF is then reconciled with Wikidata. Wikidata is reconciled with ULAN. Wikidata also has the links to the Wikipedia page. And now we've connected the circle without having to rely on labels or other, potentials for mismatch with polysemy and the same name with different people, or the same person but with different names over time.
That's so interesting. So there's enough various sources, and they're all connected, it sounds like, fairly well, that you can disambiguate most of these kind of, not second tier, but like these less well-known people. Has there been any, like, does a need ever arise to like create some sort of like canonical, like a Wikidata-like thing about them that might not clear? Like you said, there's that requirement for notoriety to get into Wikipedia. For people who don't clear that hurdle, is there enough, like that Library of Congress and other connections you just mentioned? Is that enough, or do you sometimes have to like kludge together some way to resolve these entities?
Yeah, no, we frequently create new identifiers for the people who are not notable enough to be in any of the authority systems. And indeed, the authors of books that are not published in America, we have trouble reconciling as well, for the library work, or the subjects, right? So if you have a book about someone, then you still need an identity for that person so that we can have the relationship over from the work to the person that the work is about, as opposed to the author who wrote the work. So we have more than 5 million people in group records, of which I don't know the percentage, but it's not that high, are reconciled directly with one of the major authorities. We try our best, but we also accept on every single page in the user interface feedback. There's a very prominent blue submit feedback button to then get people to write in and say, okay, no, you've misaligned this person, or you've merged two people who are really separate, or you haven't merged these people together when they should be merged, and so on. And we get feedback every day from people who often are searching for themselves and find their record in our knowledge graph, and then submit to say, oh, hey, can you update this? Or you've merged me with this other person with the same name, and so on.
Hey, now, as you're reminding me there of the scale of this, and you mentioned earlier this, the need to reconcile the completeness that any archivist, you do, like I'm a pack rat, I want to know everything and keep everything, versus like the sort of semantic tidiness that really makes something like this. How do you balance those, the volume you're dealing with, and there must be competing human interests as well, like people who want to know everything about a certain niche subject area, but you just don't have the resources. And there must be other issues as well. How do you address that?
Yeah, and this is a big challenge. It comes back, of course, to what data we have. Right? So a lot of the time in historical bibliographic records from the past decades of library cataloging, all that was written down was the name of the person. So that's all we have. Right? So we do our best to try to figure out who that was algorithmically, but with millions of people being talked about, and more records being added every day, and we don't have the person time to do that by hand. So we do rely on external authorities a lot to try to enhance and enrich the records rather than us, Yale, managing everything. So that then gives us a kind of a baseline for the work. But in terms of the sorts of information that we manage, right, that's when the link back to the ontology comes in, where there needs to be some relationship that we can express between two entities that we have in the knowledge graph. So, for example, we know where Rembrandt lived, so we have the place down to the street address, and we have Rembrandt as a person, not because we have that many Rembrandts, but because we have a lot of books about Rembrandt as a famous artist. So, there is a challenge of boiling the ocean. How far do you go? Do you then try to find all of the other people who lived in that same house? No, clearly not. But equally, we need to work with our stakeholders, and I think this is really the best practice of, understand what your system needs to manage and manage that. And then maybe go one step further, but don't try and have a single system that manages all knowledge from anywhere. So we had before we went to linked data for the discovery system, we tried to use the more traditional full text database type queries of Solr or Elasticsearch or similar. And we did so many demos to our stakeholders that the curator of American art in the art gallery said, "I never want to see another Solr demo until you can answer this question." The question was, which paintings do we have that were created by people from Europe but depict a place in America? You can't do that without a knowledge graph. It's just impossible, right? Because you have too many joins. Yeah. We didn't manage all of the information about the artists. We just had their names for some of them, right? So who is European? Well, what does European mean? Well, it was born somewhere in Europe or has a European country as a nationality. Somewhere in America? Well, that's an awful lot of places. And if you're managing the identities of the places, you need to then be able to do transitive queries to say, is this anywhere within hierarchically the United States of America? So at that point, we then went back and said, okay, let's try this as a knowledge graph, which of course suited me to no end, given my background. And we can now answer that sort of question. And with when the AI front end becomes available, you can just write that in and you get the answer. So yeah, it really comes down then to what do you need to do, what would you like to do, and what data do you have in order to do those things, and then making sure that you've got the right ontology at the back end in order to be able to answer the questions that are needed. But yeah, the trade-off between usability and completeness really is the dark art of linked data, right? So if you have every single piece of knowledge that managed in the ontology, it's almost certain that it will be completely unusable. So for example, if we tracked the data provenance of every triple, right? So which did the birthplace of Rembrandt, it doesn't come from us, but did it come from Wikidata? Did it come from ULAN? Did it come from the Library of Congress or the National Library of France or Germany or any of the other 25 different sources that we use? That would then multiply our data set by 10 because every single triple needs to have where did it come from, which could be multiple places, when did we get it, and so on. So that was one of the questions that we had to decide on in terms of scope pretty early on, because that was requested of us, and we want to know where all this information comes from, so that if something is wrong, we can go back and see if we can get it fixed. That led to the submit button as kind of the halfway house. So we track the records that it comes from, but we don't track which triples for each entity come from which sources.
I love that. That's such a great pragmatic example of like the tough trade-offs in this kind of big project. I also love that example you gave of the ability to discern which paintings depict something painted in America by a European painter. I'm going to steal that because people, those kind of it's hard to come up with those kind of examples sometimes. So that's a great one. But hey, I can't believe it, Rob. We're coming up close to time. But before we wrap up, is there anything you want to revisit from the conversation, or just make sure that you share before we wrap up?
Yeah, no, just another call out that if you would like to come work with us at Yale, we have some open positions, and for the postdoctoral researchers, we're applying for some money at the moment from an external source. So keep your fingers crossed for us, which would open up another one. That would be to work again at this intersection of AI and linked data, but for particular research questions around how, once we have all of this knowledge built out, So we have hundreds of thousands of images of text that we can extract out into a knowledge graph. Now what? Now we have this abundance of knowledge as opposed to the current scarcity. So how can we use modern cutting edge technology in order to make that knowledge more accessible so that researchers can do research, so that people can interact with the archives and enjoy the content there? Perhaps using customized on-demand generated interfaces built by Claude Code or some other equivalent that specifically understands the ontology, understands the data, understands what the researcher needs conversationally, and then can then generate this on-demand interface to be able to present the information from the graph to the user in a way that the researcher can interpret it, rather than just being presented with the hairball graph of here are all the connections. Well, that really doesn't help anyone. But a timeline would, or a map, or the list of all of the archival objects that refer to all of the components of the researcher's question.
I love this vision. I'm going to have to circle back in a year or two to see what kind of really cool architectures you built, because everything you said is completely plausible with current technology. You just have to need to hire a few postdocs to do the grunt work, and there you go. And that sounds like an amazing opportunity. I'll make sure I'll mention that in the show notes as well. Well, hey, one very last thing, Rob. If folks want to follow you or connect online, what's the best place to find you?
Yep. So feel free to email me, robert.sanderson@yale.edu, or LinkedIn. I'm happy to accept connections from all and sundry on LinkedIn. So yeah, Robert Sanderson and LinkedIn.
Excellent. Great. Well, thank you so much, Rob. I'll put those in the show notes as well, but thank you so much for the awesome conversation.
Great. Yep. Thanks, Larry. Thanks for having me.
For show notes and to sign up for our newsletter, visit our website at knowledgegraphinsights.com, and please rate and review us on your favorite podcast platform. Thank you for listening.